Are you recording? I should just send him that. Okay. All right. So, Kirchoff's laws, the first thing to do is to label your currents. And I'm going to label these guys from left to right just to be systematic. This is I1. This is also I1. Okay. This one here, guys, don't talk. That's I2. This guy here is I3. All right, I'm going to call this guy I4. And this guy's going to be I5. I know. There you go. Someplace, these other ones are funny too. There's probably an I3 somewhere as well, you know. I don't know. So this means, by the way, that we're going to have to solve a 5x5 matrix, only we don't have to do it, our calculator will do it, right? That's the beauty of this, right? Okay, so the next thing to do is to set up, I think, two of our equations then are going to be circuit junction equations, and that's because we've got two important junctions, one here and one here where the currents split up, right? Okay, and so I'm going to say that I1 equals, well, I2 plus I3, right? And I3 equals I4 plus I5. There we go, right? Yeah? The problem is, though, we can't really have equations like that that are like something equals something for matrices, right? Okay, so I'm actually going to rewrite this guy as I1 minus I2 minus I3 is 0, right? And then I3 minus I4 minus I5 is 0. In fact, I was getting to the point where I was just typing the things into the calculator as I looked at the circuits. But that's, you know, waiting for a guitar lesson and having, yeah.
How do you know that those are all equal to each other?
Oh, how do we know? Okay, because I1 splits up, just like that little quandary we did, splits into I2 and I3, right? The way we've drawn it. And if we're wrong, why, you know, we're still a little bit right. Okay. In other words, if the currents flow the other way, there's still a mathematical relationship between them like that, right? When we imagine that I1 flows this way, and it does, it really does, right? Okay, and it splits into I2 and I3, and this is conservation of mass, or charge, right? Yeah? Does that make sense? Yeah. And then I3 splits up into these guys at that junction, right? And now we're going to do some loops. We're going to do some loops, and I'm going to use red to do the loops, okay? And I always start downstream of the battery, okay? So let's do a loop this way and go. That's the first loop, right? Okay. And so in that loop, notice that we're going to have 8I1 and 3I1 and all this stuff, right? They're both going to be I1s, but let's set that guy up, right? So that's going to be 19 minus, the first one I run into is 3I1. So the rule is, if we go this way through a battery, we go up in potential, whatever the battery is, right? And if we go downstream through a resistor, it goes down. If we go upstream through a resistor, it goes up by IR, right? So it's either just the voltage of the battery. If we go this way, we go down 19. This way is up 19. This way would be down 3I1. This way would be up 3I1, okay? So voltages drop inside resistors. So minus 3I1. The next one would be, I'm following that loop, so I'm going around and I'm going to go minus 11I2. Right? And then I go minus 5I1. And then I'm back where I started, so it's 0 net elevation gain. Yeah? I just ran a nice cross-country loop. And I ended up back at the same elevation, right? So now I'm going to do another loop here. Okay, should I use a different color? Let's use brown. Marron. Le loop en marron. Okay, so now I'm going to go this way. And then there's two more loops because how do I know I need two more equations? We got to have how many equations? 5 equations, right? So this one goes here, and then obviously the next one's going to go, you have to visit all parts of the circuit. If you don't visit all parts of the circuit, there's going to be numbers pertaining to the circuit that aren't in your equations, and you can't possibly solve it then, can you? Right, so our strategy here is to visit all parts, right? And I always put the battery in there because I always feel I need to, right? I don't actually. So this one, the first thing we did was we went up 19, right? Then minus 3I1, and now we're in different territory, right? So we go downstream through this guy, and now we're this way. So this is, I'm going to take a radical step here, and I'm going to say down 5I3. Yeah? Yeah? And then we're going to go, let's see, that's 5I3. Then we're going to go down, and I'm going to take a radical thing here and say that that's minus 12I4. Yeah? Right? And now we're getting back there, right? And then we've got minus 3I1, or I'm sorry, whoops, minus 3I3. And then we're back here, and this is 5I1, is it? Minus 5I1. And now I think we're back home, right? That's 0, isn't it?
Did you combine?
Yeah, we sure can't we? Okay, and then our final loop I will do in I need a snazzy color. How about just black? I haven't used black yet. Okay, so this final loop is going to start here, go boop, 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 Betty boop, boop. Like that, right? Okay, so again, I go, the first thing I did was I went up 19, and then minus 3I1. These matrices are going to be, and then we still had to do the minus 5I3. Okay, and now we do, what is it, minus 11I5, is that right? Okay, and then still we got to do the minus 3I3. And then we've got minus 5I1. Yeah? So we need to rewrite these equations so that they're a little more matrix friendly, don't we? Yeah? Okay. So this guy here, can't I take this guy and rewrite this equation? So rewrite, I'm just going to erase on the board because I need all this space to set up the matrix, right? Okay. But I'm going to rewrite this guy as minus and minus equals 0, right? Okay, and just erase that. I need this space here. Right? And then I'm going to say this guy is minus that is 0, right? Okay. I'm going to say for this guy, just kind of crazy here, I'm going to say that this, first off, 3I1 and 5I1 is 8I1. Yeah? Right? And then I think I can say that this, in fact, I just set them up this way. Here's a little secret. Can't you rewrite that guy this way? Aren't they the same? Didn't that make sense? In fact, I just set them up that way.
How's it positive? Would it be negative?
These were both negative, but then when I put the 19 over there, it would be negative, and I made everything positive. If you look at the original equation. Yeah? So basically, all I'm saying is, and we knew this from series circuits, that in a loop, the sum of the voltage drops equals the source voltage. That's another way to say it, right, when we solve series circuits, right? Okay. And then this guy here, I can take the I1s and make this 8I1, right? And then I3s, aren't there 8 I3s? Yeah? Aren't there? Right? And then I can put the 19 over